So good morning, everyone. And this is SDF Tagger, a presentation about the SDF Tagger. This is a library to do natural language processing in which I'm working on since my PhD thesis. So it's almost 20 years that I took my PhD. And over the years, I always refined and improved it. And now is, let's say, 3-4 years that I don't modify it again. So I guess it is quite stable. And I always use this library in my projects, in my research projects, and collaboration with industry. And then I'm planning to do it again in the future. And the reason why I wanted a talk here in the Computational Foundry is as a showcase to inform everyone that I have this library. So whoever wants to do projects with me, I'm very keen to do one. Okay, so the library is available in this URL, which is a URL, a web page in my personal website for who wants to know more, wants to download it. And so, as I said, I used it in several past projects of mine. The most important of which, let's say, is this Eunovos system that is also described in this publication. That is one of my most cited work. That if you are interested, you can work there. And Eunovos was a service, a system that was distributed by the spin-off Nomotica SRL of the University of Turin. It was because the spin-off has been closed at the beginning of 2021, in January 2021, and because so when this was a spin-off of my former university at the University of Turin, but now every stakeholder took a different path. So for instance, me, I came here in Swansea, so nobody was following anymore the spin-off, and so we just sold the system, and now I don't know if it's still used. But anyway, the Nomotica was working for the Italian banking domain, so financial documents and financial regulations about the banking domain in Italy. So what we were doing is to collect all documents like legal text or case law, and to apply NLP for converting them in XML. Then we defined ontologies, and with NLP we were able to classify the documents with some machine learning, but also to extract to concepts and name identity to connect to the ontologies. And then a semantic role labeling, text classification. We were doing a lot of things by integrating there our research. And of course, SDF Tagger was one of the main modules used within this software. Okay. SDF Tagger is, in a nutshell, is an hybrid system. So hybrid means that it can be both rule-based and statistical. Okay, so we can. The idea is to generate via statistic a set of rules. So in SDF Tagger we use rules that later I can also show you. And the idea is to generate 80% the rules that cover 80% of the cases, more or less. And then we add manually other rules to cover the remaining 20%. Okay, and this also makes the system explainable, because whenever we tag something in the text, we know which are the rules, because every rule has an ID. So we can produce a log file that tells me which are the rules that led to a certain annotation. And from that, you know, explainability is explainable AI is the future, because contrary to machine learning, that is known to be a black box. So when it takes a decision, we don't know for the reason why it takes. So actually we know, because it is the decision. The reason is just the application of a statistical formula. Okay, this is the only explanation that machine learning can tell us. While when we have rules, we enable logical reasoning, and so we have logical explainability. And the three assets that are three components of this SDF Tagger is a standardized rule-based environment. And as I said, the idea is to generate statistically rules that cover 80% of recurring linguistic patterns in text. So basically, we count which words occur more often in the sentence, which patterns, which linguistic patterns, and whenever we find one, we can generate a rule that recognizes the recurring pattern in new text. And doing so will cover, let's say, 80% of the cases, as it is standard in statistical approaches, in machine learning approaches, because they follow the Pareto principle, the 80-20 rules. And then we also need, and this can be easily developed because the rules of SDF Tagger are easy to manipulate, we can develop interfaces to edit and to debug the rules and to approve them when they are recognized in the system. These interfaces can be easily built, and they will speed up and facilitate the growing, the debugging of the knowledge base. Okay, so the idea is to have, we take a text, we generate rules that tag this text into XML by connecting the annotation with an ontology in OWL. So that if we take a decision on the ontology, by backcrossing the links, we are able to know which annotation led to a certain decision. And in this sense, the system is also explainable, because this is not machine learning, this is a logical, the reasoning that we can do in an ontology is a logical one, it's not statistical one. And the rules allow to show which tags which tag led to a certain decision. And the XML standard can be can depend on the certain domain. So for instance, if we are doing sentiment analysis, we can use this XML standard that I defined in this very old publication of mine. And if we are using legal text, like in the Italian banking domain, the regulation for the Italian banking domain, like in Eunovos, we can use this commentoso that is a standard for tagging legal text. But so basically what I'm trying today is that SDF Tagger is neutral, independent of the XML format that we use for the annotation. Okay, we can use any XML format, and then we build these links to standardized OWL or RBF ontologies. Okay. So here I show an example precisely from the finance domain. This is a project that I was doing in my former university, which is Luxembourg. So my former university is Turin in Italy, and then I moved to Luxembourg, and then I moved here. So this is what one of the projects that I was doing when I was in Luxembourg. We have this prospectus from Schroeder Investment, that is an investment fund, and we have them available in PDF. And here we can just add some rules that are able to recognize the structure of the PDF. So to divide into titles, sections, subtitles, subsections, etc. And here we can also put rules that look for the size of the font, the size, the color of the font. So SDF Tagger also allow to integrate this metadata on its rule. So for instance, if we see, we find a very high, a bigger font, this is a title, especially if it is also colored in a different way. So the SDF Tagger is able to tag it as a title. And then it recognizes the text between the titles is a section. So with some rules, we are able already to achieve this. That is better than working on a PDF, because we already have the several parts of the text tagged. Then we can look for concepts, okay, instances, concepts, interesting concepts within the text. So for instance, European Monetary Union, or the fund invests at least 70% of its assets. These are relevant concepts that characterize the investment fund. For that, we can simply add rules that again recognize European Monetary Union and tag it as an organization, or this is tagged as a quantity, this is a location, this is another quantity, and this is an object. In particular, is a currency. Okay, because the investment fund can be in euros, in dollars, in rubles, even if not many of them are left. But so here, this is a relevant concept that characterize the investment fund, that we are interested in tagging in order to reason on the investment fund. Okay, here we can have a query, give me all the investment funds that are in euros, okay? And then we filter only those that define the currency in euros. But as I said, we can do more. So these and these rules can be added manually. Okay, we put a rule that says if you find the euros, dollars, we generate rules for every kind of currency that we have in the world, and tag it as an object in the text. And this can be added manually with a script that generates some of them. But then we can also generate them statistically, as I said, because we just count the occurrences. Okay, so we have a Metarule that look for the most frequent expression in the text. And so, for instance, we find that equities of companies is a recurrent text. So it denotes a relevant concept. So the idea is that the more the linguistic expression is frequent in the text, the more it's likely that it denotes a relevant concept. Okay, and then of course we have other statistical, because also the expression as soon as possible, the collocation as soon as possible, is frequent in text, but this is not relevant, and because it occurs in every text, it doesn't characterize a particular text, and but for that there are other more advanced statistical measures like TF, IDF, etc. Okay, so with what I'm trying to say is that with some statistical formula we can try to automatically recognize what are the relevant concepts in a certain domain, okay, or in a certain particular class of investment fund. So, for instance, we can find out which are the new trends now for the investment funds, and we find out that the green technologies is recurrent in the current investment funds. So, from that we understand that current investment funds most likely invest in green technologies, or on a particular green technology. Maybe they invest more in windmills rather than in nuclear power plant or other nuclear power plant, the new generation nuclear power plant, the one that should work not on the separation of the atom, but on the union of the atom. But okay, now I'm making a digression. So by the way, with some statistics, we can try to identify which are the relevant concepts. And then we can think about a simple interface that tells me, look, I found this expression rather frequent. Does this correspond to a relevant concept? With a button, I can say yes, no, and then when I press yes, the system automatically generates the rules that recognize the expression and all possible variants of the expressions. So for instance, equities of company, equities of the companies, or the equities of a company, all these kind of linguistic variants that denote the same concept can be also automatically generated with some script that works on the linguistic expression itself in order to recognize also the variants. And okay, so this is the first step to recognize the text. The step that can be done at the same time is to connect these chunks of text to relevant concepts in an ontology. So for instance, European Union can be associated with an ID, org1, and this is part of the class organization. This is a location, an object, etc. And we can also do relations between the concepts. So for instance, equities of company in countries participating in the European Union. Okay, the system automatically finds the patterns that connect this tagged concept with this tagged concept. And again, an interface suggests me, look, I found this expression rather frequent in the text. Does it denote a semantic relation between the two concepts? And then I say yes. And then the system asks me, give me a name for this semantic relation. I call it within. Okay, and so it automatically creates a semantic relation between this individual and this class. Okay, so we are not interested in equities of companies, any equities of company, but only the one within the European Monetary Union. Okay, we are not interested in the one from Russia, for instance, because the new investment funds they exclude. So okay, and in this way again we are tagging the text semi-automatically with these smart interfaces. We are building a knowledge base of text automatically tagged with respect to an ontology of concept on which we can reason. Okay. And this is so having said that, this was a general introduction with about SDF Tagger. Now I'm doing there is an ongoing collaboration between the Legal Innovation Labways, in which I'm proudly a member, and which is part of the School of Law of Swansea University. And so again, I'm a computer scientist, but I work in legal tech in the School of Law, and the reason why I'm doing this this presentation is to showcase myself and to look for new collaboration in the computational Foundry or in finance. And so this is a research collaboration that we are currently carrying out with this company that is called Zeidler Group. This is a law firm. Okay, so these are lawyers. But they have the problem of they have to analyze prospectus and KIDs. Prospectus are when documents that the investment funds put at disposal and to sell the fund. And KIDs are legal documents of 2 pages that contains the main figure of the investment funds, the main figure that are required by the law. Okay. One of the long-term project that we had in mind is to build an NLP that is able to check if the prospectus and the KIDs contain consistent information, because in many big investment funds like Schroeder, these are written by different offices. The prospectus is a marketing document, so it's written by the marketing department of the company. The KID is a legal document, so it's written by the legal department of the companies. There are different people working in these offices, even if the church is the same. They are in different offices, and not, of course. We can see with the same is happening with our colleagues. Not always the colleagues talk each other. Not always the colleagues like each other. Okay, and so each of them work independently, but still they have the documents must contain the same information. Okay, and there are a lot of mistakes. Okay, because one thing is written in the prospectus, another thing, inconsistent, incompatible thing is written in the KID. So for instance, here we have an example. So the ongoing charges that are in the KID, okay, these are the ongoing charges of the fund. This is the percentage of money that they take from you every year if you subscribe on the fund. And as far as I remember, Jen can correct me. And the ongoing charge in this KID are 1.68. In the prospectus, these are not reported, but there is written that there is a management fee and a service agent fee. Okay, so basically we have that this value here has to be lower than the sum of these two. Okay, and we can make this check either manually. Okay, and it's very tedious, it's very error prone, it's very time consuming, or we use SDF Tagger that tags the ongoing charge here, tags the management fee here, the service max. It links each of these value to a concept in the ontology, and then in the ontology we implement a simple logical check that look for that all the value are consistent with each other. Okay, this is what we should do in the future. But then more checks also in this procedure. Now instead of keep talking, I would like to show you what I'm doing with them. Okay, so basically we have this is the software that I developed that incorporates SDF Tagger. SDF Tagger is here in the library. This is the NetBeans here. I'm using SDF Tagger, and I can show you the here in the configuration file we have I generated all the rules for English, for German, for Finnish, for Italian, and the Netherlands. So of course SDF Tagger is also language independent, because so it can be executed on any kind of language. It doesn't work only for English or for Italian. And here in this demo, I did these languages. Okay? And here I just want to show you, this is, for instance, a rule. This is an SDF Tagger rule, SDF rule, that recognize the charges. So you see, these are rules in XML, and this has been generated with a script, okay? But in principle, we can also edit them by hand, okay? But this is more complex. Of course, the idea is to generate these rules automatically. But since these are in XML, so this is a big difference with respect to standard machine learning, in which we have a neural network, we have a matrix, a support vector machine, a matrix of numbers, okay, that is unintelligible. These are written in XML and they act directly on the word, so they can be debugged even by hand, okay? So these are what I'm doing here is in the first part of our collaboration, they provide me KIDs, okay? So this is a KID, okay? A KID stands for Key Investor Information Document, okay? So this is a KID of an investment fund from the Netherlands that is called Robeco. And here, this is, I don't know if you ever invested some of your savings in funds. This is what the bank provides you when you want to subscribe to a fund. A KID, it is a legal document that is required by law, at least in Europe and in UK. Is in the US is not, but there is a plan to make it one in the future. And so in which there are the main figures, the objective and the investment policy of the fund, the risk profile. This is very important. So this investment fund is quite risky because it has 6. Then the charges, you see the entry charge, how much you pay when you subscribe the fund, the ongoing charges, this is the fee, the annual fee that you pay to remain subscribed to this fund, the exit charge, this is 0, so you can leave the fund whenever you want for free, etc. And then there is the currency, the first quotation date, practical information, etc. So a lot of things written in PDF. These guys from Zeidler, they currently analyze this by hand. Okay, so they open these KIDs one by one and they enter the data in the database. Okay, this is completely idiotic and is a lot of time consuming. So they came, of course, they could have gone to IBM Watson, and IBM Watson is able to extract all the data because they use a rule system like SDF Tagger. But then IBM Watson is very expensive. Okay, so instead of paying a subscription to IBM Watson, they came to me and I told them about SDF Tagger, and I developed for them a software based on SDF Tagger that is able to extract all the data that they are interested in and to generate output file. So now these are all the output files that correspond to this PDF. Now I run the program that is here, and I extract. So this is the program that is running, and here in this output folder, after a while, because at the beginning it has to raise all the libraries. Give me a second. One. Okay, so this is the file. So the software is extracting the data from the PDF one by one, and it produces these files. And these files inside, they have all the data they are interested in, like ongoing charge, 1.20%, okay, performance fee, none. They are also interested in the section, in the text, written in HTML. So this SDF Tagger is also extracting the text within the section here and to rewrite them in XML, in HTML, because this is something that they use. I don't know for what reason. Maybe they post the KID on the website. I don't know what they do, but they told me we need also this text in HTML. Can you do it? And of course I can do it. Here it is, the result. Okay. And by the way, this demo is also online. You can use it. You go to this link that is on the web. Let me see if I can put it in the chat here in Zoom. I cannot find now the chat. I don't find the chat, but if you are interested, just write to me. So this is a website in Swansea University of the Legal Innovation Lab Ways, because we are doing a research collaboration. So I don't give them the software. I don't give them these. These remain on our server. What I give to them is a way to. This is not the right demo. Sorry, it's this one. This is the right demo. The key onboarding tool, research collaboration between our lab and Zeidler. Here, this is how they use the service. They select a PDF, they put it here, they upload, and here on the server there is my software that return the same annotation that you see here. Okay, so this is how we deliver the service to them. Okay. Now they like the result, so we are in the process of defining a license for them to use this software. So they will pay the lab, the university, in order to use this software. Of course, we don't give our IP for free. Why should we? And also, if we do it, we could even be blamed that we were bribed. So we could even to be double stupid. First we work for free, and then we run into legal troubles. So we sell them through a license. Okay, this way, and now we are defining this agreement together with Agora IP, which is our wonderful technology transfer office. Okay, and so this is what I'm doing for them. Okay, then we should also I also develop an interface for them. But now this is the part that they want to redo themselves, because they want an interface that interface directly the system. This doesn't work. Okay. So this is a kind of interface where on top you can see the kid investor information, the PDF, and here on the bottom you can see all the data that are tagged. So an annotator can scroll down. You see here introduction or objective investment policy, because they want it in PDF. So what they can do is to check one by one if the data extracted are the same that they wish. Okay, they want it tagged in HTML, so we have a paragraph here. We have a break line is here. The investment horizon over 5 years, investment horizon over 5 years, then break line, and they have the rest of the section. So this is a simple interface that they can use in order to double check the result. But by using an interface like this, of course, it's much better than controlling the result directly on the text file. And an interface like this can really speed up their work. Okay, because before they do everything by hand, so they come here and they cut and paste, like the value of, they come here, they cut and paste ongoing charge like this, they copy and paste into their database. On the other hand, if they have an interface like this, they have just to check in parallel the value that are extracted. At the end, they press OK, and look, everything is inserted in their database. So they take 5 minutes, while before they were taking 1 hour, thanks to SDF Tagger. Okay, and okay, so same for you. As I said, I'm here to showcase what I'm able to do. So if any of you needs something like that in your project, so for instance, Jaina, if you have a project in finance similar to this, and you can contact me, and I can be your technical guy. I can be a work package leader of a work package that devoted to build a software an NLP software based on SDF Tagger, together with an ontology that is able to perform checks like this, okay, like the one of the ongoing charges. This just a note that there is also a worldwide initiative. Jen, I don't know if you know that. That is a financial industry business ontology. They are defining this is in the US, but it's supported by many banks and associations. There is also Sainsbury Bank that among the sponsor of this ontology, that to define an ontology for concepts in the fund investment domain, in the business entity domain, let's say loans, market domain, etc. Okay, this is something that is expected in the future to be the standard for legal documents in the financial domain. Okay, so this will be the conjunction, the bridge between legal tech, what I'm doing, artificial intelligence, and finance. Okay, because Jane knows very well, and also Michael Backel confirmed it. In finance, there are still a lot of operations that are still done by hand. Like and this is now we have the technology to do it without to do it automatically or semi-automatically without paying a lot of money to buy IBM Watson. Okay, because again, all what I show you with IBM Watson can be done very quickly, even better than me. But then we go to see how much they charge to use their services. Okay, so this is to use an efficient and cheap service at the same time. Here just a slide that the rules of SDF Tagger as a priority, and is allowed to implement the overreading. So you see every rule here as a priority number, and I don't know if you can see. Maybe I can a bit of zoom, but now I don't have the map. But doesn't matter. Here there is a priority, and priority is used in order to implement overreading. That means that we can generate statistically rules that cover 80% of cases, and we assign it a lower priority. And then by hand, we add the rules with higher priority. Okay, SDF Tagger execute the rules according to the priority. So first he executed the high priority rule and then the lower priority rule. Okay, and this can be done recursively because so we can always define a higher priority in order to override the rules. Okay, in order to converge to the 100% of accuracy, even if 100% of accuracy is just a dream, but in principle we can do it. And also we can if we generate a rule, and then we have a thesauri or a database, or we can use the World Wide Web to look for variants of the rule. We can generate, starting from the rules, we can generate other rules with lower priority that recognize the variants. Okay. So for instance, in Luxembourg, I was starting a research collaboration with another company that they were doing, what's the name, anti-money laundering, know your customer procedure. These are also very popular, especially in the financial domain. And they had the problem that to recognize names of ships, okay, when in Africa, if this ship is connected to criminal activity, okay, and sometimes they told me they have the full name of the ship, sometimes they have the name of the ship without a letter, okay, because they made a mistake, sometimes they have the code of the ship, okay. And so they have this problem that the same ship is referred with different variants of the name, okay? And we were discussing about using this SDF Tagger in order from the name of the ship, then you can search online. Like they told me, in many cases you find in online newspaper the name of the ship, or in a PEP list in this kind of documents that are prepared by the auditor, by the authorities. That you can find the variants of the other names that are used in order to refer to the ship. Okay. By using this knowledge from one rule, we can generate all the other rules that recognize the name of the ship. And so it can improve your know your customer anti-money laundering procedure. Okay, just an example. Here I put another example. This is what I was doing in Eunovos. So I'm afraid this is in Italian, but I can translate for you. This is Autorità Nazionale per l'Anticorruzione, means National Authority for Against the Corruption. Okay, is an auditor, an institution that we have in Italy, and this text that we can find correspond to this rule that simply check that the several because here ANAC, this is the acronym. Okay, so we find this followed by the acronym. This was found within a case law. Okay, because in case law, usually they introduce the entity and then they put the acronym. And then in the rest of the case law, they only use the acronym to refer to the same entity. Okay, so from this rule, we can easily generate a rule that recognizes the name and the acronym separately. And we assign a lower priority. Or we can, anti-corruzione can also be written like this. Or maybe this is recognized even with other rules. So from this, we can generate rules that simply look for the prefix in every word, and every time it finds the prefix, it breaks the word into other three words, like this, and like this and like this, sorry. And it generates a new rule that is able to recognize the variant of this name, okay? Anticorruzione, we can also say Autorità Nazionale per l'Anticorruzione, which is a national authority for the anti-corruption. Maybe in some text, someone write it with the article and with the preposition, okay? Again, no problem. We generate variants of rule automatically that insert preposition and article between the words in order to recognize these variants. And finally, we can also go on Wikipedia. We find Autorità Nazionale della Corruzione. We search for the automatically. This is done all automatically by the same script. It goes on Wikipedia, so he uses an external knowledge base. He land on the Italian Wikipedia page. Then he take the corresponding English page. It takes the title and it generates also the title in English. So we are able to generate, to recognize this, to automatically recognize the English translation of this institution. Okay, and with, of course, all the variants, because here is written anti-corruption, so maybe anti-corruption without the hyphen, in another font, etc. Okay, because you know that there are several kind of hyphen. Okay, it's not always the same, and so that automatically we can generate all these variants by using external documents, external knowledge base, as I was illustrating here. Okay, so this is the flexibility of SDF Tagger, because the rules, the parameters of the rules are flexible enough in order to account also for these linguistic variants. Okay, and that's all. So thank you. I don't have anything else to show. And any questions? Ah, Bethan, you're here. Hello.